Hello and thanks for checking out FasterQuant, automation tools for quant traders. In this video I'm going to do a deep dive discussion about how the FasterQuant application's Portfolio Optimization Runner works. The Portfolio Optimization Runner will backtest, filter, and rank different strategy combinations. Let's see how it works. Let's take a look at the Portfolio Optimization Runner config file. This config file is going to target the strategies that were generated via the edge test and order optimization config files that ship with FasterQuant. Before we cover the properties in this config file in detail, let's note that the definition folder's property array values shown here indicate that the runner will load all strategies and their order combination permutations from the 52-week high and snapback directories, which can be seen here. Next, let's run the Portfolio Optimization Runner. Here we can see that 450 strategy portfolios were backtested. 396 passed the portfolio filters, and the top 20 portfolios were compared against our benchmark in the output generated. Let's take a look at the output. Opening the results file, we can see the result metrics for each strategy portfolio that were ranked highest based on the portfolio scores defined in the config file. Next, let's take a look at the Portfolio 9 results to see some additional information. With the Portfolio Backtest Results HTML file, we can browse to any of the generated portfolios and open the Portfolio Backtest Results JSON file. Here we can see the equity curve and yearly returns compared to the benchmark we had defined in our config file, with a blue line and bars on the respective charts representing the portfolio backtest results. Also shown here are the trades generated for this particular portfolio backtest. Shown here is the output for the strategy portfolio we just viewed the results for. Included in the output are all of the strategy definitions and portfolio backtest config file, which will enable us to backtest this portfolio at a later time. We also have all of the algo terminal source code generated. Next, let's analyze the portfolio optimization config file in detail. The beginning balance and benchmark symbol properties are set to 100,000 and ES respectively. The commission calculator property is of interface type iCommissionCalculator and is set to the commission per unit class instance with an amount of 2. The portfolio name and risk name properties are name prefixes that will be appended with the corresponding portfolio output number, and these names will be set in the algo terminal portfolio and risk management source code. We already covered the definition folders property. The generate code property will generate algo terminal, trading strategy, portfolio, and risk management source code for each strategy portfolio. One important thing to note is that classes that implement the iDerive Data Configurator interface, for example the ATR configuration class, must be defined in the method definition JSON file if generate code is set to true and the class is used in a strategy. Also keep in mind that pseudocode for each strategy of a portfolio is available, even when generate code is set to false. As with the edge tests and order optimization runners, the limit trades property set to false will instruct the backtester to add every signal as a trade for each strategy backtest. A value of true will cause the backtester to prevent the same symbol from being in more than one trade concurrently. The max risk percentage per trade property defines the maximum account risk percentage per trade. The strategy same trade percentage threshold property is used to categorize two strategies as the same based on the percentage of trades they both have. We will elaborate more on this in a bit. The result output count property shown here will result in the top 20 strategy portfolios being saved. The portfolio strategy max positions property is of type portfolio max positions and is used to define the maximum number of concurrent open positions per strategy. Here we can see that any of the 52-week high strategies will have a max concurrent position count of 2. And any of the snapback strategies will have a max concurrent position count of 1. The portfolio strategy group max positions property is of type portfolio max positions and is used to define the maximum number of concurrent open positions across a group of strategies. Here we can see that the 52-week high and snapback strategies will have a max concurrent open position count of 4 across all of those strategies. And any of the snapback strategies will have a max concurrent open position count of 2 across all of those strategies. The date range property defines the date range for each portfolio backtest performed as part of the portfolio optimization. The portfolio filters property is set to minimum profit factor filter of 3 and a maximum drawdown filter of 25%, which means that only portfolios passing these filters will be saved. The portfolio strategy filters property is a collection of portfolio strategy filters arrays used to create combinations of result filters applied to the strategy categories. The portfolio scorers property is a collection of result scores used to rank the portfolios based on their backtest results. Here we have the maximum total result score and the maximum profit factor score, each weighted equally at 50%. The portfolio strategy scorers property is a collection of result scorer arrays used to rank the strategies based on their backtest results. Here we are going to test selecting strategies based on different scores. The remaining properties all have to do with code generation and are currently set for Algo Terminal. New code generators can be written and their corresponding types, which implement the appropriate interfaces, can be assigned to these properties. Next, let's look at some pseudocode to demonstrate the process flow of the Portfolio Optimization Runner. Here we have defined order combinations for strategy 0, 1, and 3. Let's see what that looks like on the file system. Note that the number of folders in each directory match the number of items in the strategy's collections. Now, with our strategy same trade percentage threshold property set to 70%, and assuming base strategies 0 and 1 had 70% of the same trades from the original edge test run, we will combine their strategies with the different order combinations, which would give us the new collection shown here. Next, for each portfolio strategy filters combination, and then for each portfolio strategy scores combination, we will filter the strategies based on the current filter combination and then score the strategies in each collection and then choose the highest ranking strategy in each collection. Lines 24 through 32 show this process. Next, the portfolio strategies will be back-tested together based on the trades already loaded in memory from the order optimizations, and the results will be saved if the backtest results pass the portfolio filters. Finally, we will rank the portfolios and save the top n number of portfolios based on the value of the property result output count in the config file. That concludes this video tutorial. Please see the other video tutorials at FasterQuant.com to learn more. Thanks for watching.